it's really bright and your eyes are dialed down, they're stopped down, and the stars are a lot dimmer than what the ambient lighting is. So even though the stars are there, you cannot perceive the stars with your eyes. If you had instruments you could measure, but the contrast between the bright and the dark is such that you can't see stars. It's completely different, though, after orbital nighttime, and then the stars come out in all their glory. Yes, for nighttime imagery, I like to keep the shutter speed greater than a half a second. And that's because of not only orbital motion, but the pitch rate of station will make everything blurry. Earth will be blurry, and the stars will not be pinpoints. And so that is sort of the thing you have to set first, and then you got to tweak f-stop and ISO to suit. And at nighttime, you use the maximum aperture or smallest f-stop that's available to your lenses, and I like fast glass lenses that have small f-stops. f1.4 and f1.2 to me is the entry level for doing the nighttime imagery. And then after that, it's how much ISO or gain on your sensor chip. How much gain can you have and still keep the electronic noise acceptable? And that's what you're always juggling around. And 12,800 is typically the highest gain that I like to deal with. I prefer ISO 3200. And then with fast glass, f1.2, f1.4, and then a shutter speed of around a half a second. And that'll give you pretty good exposure for nighttime imagery. Not necessarily. It's a whole lot brighter with your exo-atmospheric. You just look at the solar flux on Earth in, noontime summer, you're probably talking 700 watts per square meter. And on orbit here, low Earth orbit, we're talking 1,300 watts per square meter. So it's almost twice the intensity. And if a shaft of sunlight comes through the cupola window and falls on your face, you really know it. So it's really intense here from illumination, and about three stops brighter than what you would do for seeds on Earth. So the Sunny 16 rule, you need to modify a little bit by about 3 stops. And for ISO during daytime, I like to shoot at the optimum ISO for whatever sensor you have in your camera. For the Z9s that we use, that ISO from the reading I've done is right around ISO 500. So I set the ISO to 500 and then dial in. I like to shoot the lenses somewhere around f5.6 to f11, right in the sweet spot for their resolution, and then shutter speeds to allow that. It's nearly impossible to get good video in a place like the cupola because it's so bright outside and it's relatively dim in the cupola. It's all black because you want it dark. And the video camera, Earth and all the surroundings would just be snow white, washed out if you exposed it for the cupola. And if you exposed it for Earth and Earth views, then you'd be so underexposed you couldn't see anything. And what I did here for this mission, I got NASA to fly neutral density filters form cut for the cupola windows. And this is something that the Hollywood boys do. The big boys in Hollywood, they'll cover windows with neutral density filters to match indoor seeds with outdoor. And what we've done here with these filters that are on, there are 4 stops, 4 f-stops, darker. And if I were to, let me give you a demonstration here. I'm going to peel the neutral density filter off of this window behind me, and you'll see what happens. Yeah, and if we brightened the inside of the cupola to match the outside, it would be like sitting under a sun lamp, and you'd start to sweat, and your skin would be all shiny, and you'd look more like a lizard than you would a human being. Okay, for daytime photography, I like this setup here. It's a Z9 with a Sigma 50 to 500 millimeter zoom lens, and this does an outstanding job of sort of capturing Earth views. If you really want to zoom in with a telephoto lens, then we have a series of prime telephoto lenses going from 200 millimeters, 400 millimeters, and we've got an 800 millimeter, and then you could put doublers on those. So if you're just shooting for maximum resolution and effect, I'll go for a prime lens. If it's just gee whiz stuff, then I'll use a zoom lens. And then we have, let me reach over here. We keep 3 or 4 or 5 cameras in the cupola. This is a camera, a Z camera. It's set up with a 28 millimeter f1.4 lens. And during daytime, you'll do a series of wide angle shots as well as the normal focal length, say 30 to 70 millimeter, and then going into a telephoto. We haven't taken the Z cameras out on spacewalks yet. We're getting ready to do that, and that will be the first level of testing, not only for upgrading cameras on station, but also for the Artemis missions. Yeah, it's tough, and I'm still struggling with that. For on Earth, it takes 2 minutes for the disk of the sun to set. On orbit here, it's 7.5 seconds. So you go from full bright sunlight to dark, dark, dark in 7.5 seconds, and to keep a camera happy recording images through that transition is really tough. I've not yet been able to my satisfaction, record the day-night transition, but I hope to do that later on with this mission. I've got a couple of tricks up my sleeve where I'm going to be running 2 cameras simultaneously synced, and they'll be set up with radically different settings, and then afterwards a high dynamic range imagery can be ilked out of that, but I haven't gotten around to doing that. We've been busy doing our mission, and all this photography stuff just has to be done in your off-duty time.